Hello, A1 and A3 chemistry. Today in class we weren't able to discuss how to determine the volume of your copper rods or the thickness of the two aluminum foil samples that you have. So I told you I would make you a video explaining how you use mass and density to calculate the volume and the dimensions of the aluminum foil. So I'm going to use my tiny science laboratory table. I'm very excited. And then we will go through those calculations and then you'll be able to finish the lab that we were working on in class today. Next class, we're going to use our pennies and the data that we collected when we measured the mass and the volume of those. The quiz that I assigned today will cover only what we went over in the data collection and data analysis today. So it will be calculating density if you are given mass and volume. All right, I hope this helps. If you have any questions, just let me know. Okay, we are going to look at your lab. Question number 21. So question number 21 is asking what is the volume of your copper rod? Last week when we were collecting data, you measured the mass of your copper rod, so I'm going to do that right now. Every time I turn on the balance, I'm going to make sure it's in the right units. I'm going to go ahead and tear the balance just in case. Now, my copper wire has a mass of 1.28 grams. All right. If you look at question 21, it tells you that we can determine the volume of this piece of copper because we know what the density is of copper, and then we know the mass of this particular piece of copper. So density is equal to mass divided by volume. And we know that the density of copper is equal to 8.96 grams per milliliter. And we know this because we looked it up. Question 21 first asks you, what is the mass of your copper rod? So that is this value right here. And then the second question says, if density is equal to mass divided by volume, what is the volume of your copper rod? And it asks you to take a picture of your calculations and then take a picture and then post them in the space below. In physics and in algebra, you learned how to rearrange equations so that you can solve for the different variables that are in that equation. So density equals mass divided by volume. We measured the mass. We looked up the density. And the volume is what we're trying to calculate. So if we, okay, Choco, I am trying to make a video. I'm sorry that I'm not giving you attention. Okay, just ignore her. Just ignore her. She likes to act up. Okay, if you multiply both sides by the volume, then the volume cancels out. She hears a dog outside. Do you think you're going to get that dog? Choco, no. Stop it. You have no way of getting that dog. Okay, Luna, no, not both of you. Oh my gosh, I knew this was going to happen. We're just going to keep going because you're not the boss of me. All right. That means that mass is equal to the volume times density. Then if we divide both sides by density, we finally get volume by itself on one side of the equation. And we find that volume is equal to mass divided by the density. And the reason we did this once again before we were so rudely interrupted by Choco and oh, did you hear that? Are you sassy with me? Okay, see, this is what happens. Luna, Choco. Oh my gosh. I really am in charge in this household. There's not even a dog out there. Y'all are trying to make me look bad. Choco, Luna, stop it. Come here. Hey, that's a good girl. I'm sorry. I'm sorry. Yes, you really are in charge. You're really in charge. We all know that. Yes, we know. Yes, yes, yes. Money, food. Okay, sure. Later. Let me finish the video. All right, so we know that volume is equal to mass divided by density. We did this because we don't know what volume is. We know what mass is. We know what density is. So if we rearrange our equation, we can calculate volume using the information that we have measured. So let's just plug in the numbers. Volume is equal to the mass, which is 1.28 grams, divided by the density of copper, which is 8.96 grams per milliliter. And if we do the math, we get 1.28 divided by 8.96 is equal to 0.14 milliliters. The grams cancel out, and everybody knows that the denominator of a denominator ends up in the numerator, and so we have milliliters in the numerator, and that's good because volume is measured in milliliters. And now we know that this piece of copper, if we were to put it in a bathtub, the volume of the bathtub would rise 0.14 milliliters. All right, so you will do the same thing for your piece of copper. You would take a picture of your calculations and then you would upload them into the assignment in Schoology. All right, if you have any questions, just email me and let me know. All right, welcome back. In the lab that we performed last week, you had two pieces of aluminum foil, and we folded them up into two different shapes just so that we could keep track of which piece of aluminum foil we were collecting data from. And remember that for each of the pieces of aluminum foil, we measured in centimeters the length of the aluminum foil, and then we measured the width of the aluminum foil. And then one of the pieces of aluminum foil, we folded it up into the shape of a triangle. And then we took our balance, and when we use a balance, we always check the units. So this one says grams, that's good. I always tear just in case. And then we got the mass of our piece of aluminum foil. We did that for the triangle and we did that for the square. And it may seem like these pieces of aluminum foil are two-dimensional. We know they're three-dimensional, but it may be odd to think of the width of a piece of aluminum foil. One of these pieces of aluminum foil, either the one you folded up like a rectangle or the one that you folded up like a triangle, is heavy duty aluminum foil, and the other is just regular aluminum foil. Neither one is tinfoil, because we know that tinfoil has not been produced since World War II. Even though the name persists, this is in fact aluminum foil. My pet peeve, but I won't keep going on about that. All right, so one of these pieces of aluminum foil is heavy duty and one is just regular. And that is your job, is to figure out which one was the heavy duty aluminum foil and which one was the regular. And you'll figure that out by determining the thickness or the width. All right. I have written down the data that we collected last week when we were measuring the length and width and mass of our aluminum foil. So this was my triangle piece of aluminum foil, and these are the measurements we made last week. We measured the length, we measured the width, and then we measured the mass using our balances. And the density of aluminum is 2.7 grams per milliliter. So I looked that up on the internet. And we're going to use the density of aluminum, the mass of our sample, and the width and length of our sample. With those data, we will be able to calculate the height of the aluminum foil. So there is a thickness to the aluminum foil, and that is the height. It's weird to think that the aluminum foil has thickness to it, but the two pieces of aluminum foil that you were given, one is heavy duty and one is regular. So you were going to determine the height or the thickness of each piece of aluminum foil to figure out which one is the heavy duty aluminum foil and which one is the regular. We'll be able to calculate the height of each piece of aluminum foil using the equations that we have been learning and pulling from our past, and we are going to resurrect some formulas that we may have repressed or pushed way down, but we are going to bring them back. If you look at your lab, question number 22, you begin with determining the height of the triangle piece of aluminum foil. And question A asks you what was your mass of your aluminum foil. So the mass of my aluminum foil was 2.02 grams. The next question, B, what was the length of your triangle aluminum sheet? And so the length of mine was 14.95 centimeters. And the width of my triangle piece of aluminum foil was 16.25 centimeters. All right, and then it tells us we will use the above information to determine the height or thickness of the triangle aluminum sheet. And for question 22, it asks you to give this information and the answer. All right, then it says, let's determine how thick or the height of your triangle aluminum sheet. And in geometry, we learned that for a cube, see if I can draw this better than I did earlier. Hey, that's not too bad. All right, so the volume of a cube is length times width times height. Okay, and height, width, and then length. Okay, so once again, our aluminum foil, we have the dimensions in this direction, and we're trying to figure out how thick it is. Okay, so question 23 says we can calculate the volume of our triangle aluminum sheet because we know the mass of our triangle and the density of aluminum. Question 23 then asks you, what is the volume of your triangle aluminum sheet? So we look again at our equation that density is equal to mass divided by volume. And as odd as it sounds, the volume of this sheet of aluminum foil is, we do use this equation for the volume of a cube because this has length, width, and height, or this thickness. So this is a very smushed cube. So this volume is also this volume. If we wanted to get the density of this cube, we would take the mass of this cube and then divide it by the volume, and that would give us the density. So this volume and this volume are the same thing. Now, we know that the density of aluminum is 2.7 grams per milliliter. And you know that because I told you that, and I know it because I looked it up on the internet. So we measured the mass. We have the mass, so we have this. And we have the density of aluminum, so we have this. So if we rearrange our equation, we can determine what the volume is of our piece of aluminum foil. So we learned in, we learned in physics, and we've learned in algebra how to rearrange equations so that we can solve for the different variables. So if D is equal to M over V, we can solve for V by multiplying each side by volume. And then if we divide both sides by density, then we get that the volume is equal to mass over density. And we have the mass. And we have the density. So, use my calculator on my laptop. So 2.02 divided by 2.7 equals 0.75 milliliters. The grams cancel, and the denominator of a denominator goes into the numerator. So we know that the volume of this piece of aluminum foil is 0.75 milliliters. If we put this in a bathtub, the water would rise 0.75 milliliters. All right, so now we know the volume as well. So we can add this to our list of values that we know. We now know that for our piece of aluminum foil, that volume is 0.75 milliliters. And if you notice, we know the length, we know the width, and we are trying to determine this value right here. Once again, just like we did with our density equals mass divided by volume, this equation for volume equals length times width times height. If we want to solve for height using algebra and what we learned in physics, we can isolate this variable by dividing each side by length times width, and we get the height is equal to the volume divided by the length and the width. So now we just plug in our numbers. Volume is 0.75 milliliters. And then our length was 14.95 centimeters. Don't worry about the centimeters and the milliliters. We're going to come right back to that. Width is 16.25 centimeters. And we know that 1 milliliter is equal to 1 centimeter cubed. So we can rewrite this as 0.75 centimeters cubed over 14.95 centimeters times 16.25 centimeters. So I am going to do this on my calculator. 14.95 divided by 16.25 equals 0.00308 centimeters. So to write this in scientific notation, 1, 2, 3, so 3.08 times 10 to the negative 3 centimeters. So that means for my triangle aluminum foil, the thickness is equal to 3.08 times 10 to the negative 3 centimeters. Now, you will do the same calculation for the square piece of aluminum foil. Then you'll compare the thickness, and whichever one is the thickest is the heavy-duty aluminum foil. All right, if you have any questions, just email me, and I am happy to help.